Look closely at a glass of water. Seems utterly ordinary, even boring. But chemically, it's one of the strangest substances we know. By the ordinary rules of chemistry, water should be a gas at room temperature, like its molecular cousins. Instead, it stays a liquid, and then it breaks rule after rule that other liquids simply obey. Scientists have cataloged dozens of ways that water misbehaves. Let's begin with the one sitting in your freezer. Nearly every liquid grows denser as it freezes, so its solid form sinks. Water does the exact opposite. Freeze it and water expands by about 9%, and the ice floats lightly right on top. That's why forgotten bottles crack in the freezer, and why water pipes can burst on a bitter night. The secret hides in the molecule's shape. 2 hydrogen atoms bonded to 1 oxygen, sitting at an angle. As it freezes, those bent molecules lock into an open, 6-sided lattice with empty space trapped inside. That roomy structure makes ice lighter than the liquid, so a solid genuinely floats on its own melt. Liquid water is strangest at 4 degrees Celsius, the precise temperature where it becomes densest of all. Cool it below that and it expands once more, defying the shrink-as-you-cool logic of almost everything. This quiet quirk saves life on Earth. Picture a deep lake in the dead of a freezing winter. Ice forms on the surface and floats there, sealing the water like a lid instead of sinking down. That floating cap insulates everything below it, keeping the water liquid so fish survive the coldest months. If ice instead sank, lakes and oceans would freeze solid from the bottom up, killing nearly everything. One strange property, and it's the whole difference between a living planet and a lifeless block of ice. Now fill a glass to the very brim, then add drops slowly. The water bulges above the rim. That trembling skin is surface tension, and water's is the highest of any common liquid but mercury. Its molecules grip each other so tightly that the surface behaves like a thin, stretched elastic film. It's strong enough to carry insects, so water striders skate across a pond without ever breaking through. It's the same force that pulls falling raindrops into tight, near-perfect spheres as they drop through air. That clinginess also lets water climb. Dip a thin tube in and it creeps upward against gravity. Trees quietly exploit this, drawing water from their roots up to the highest leaves with no pump at all. The tallest redwoods haul water more than 100 meters into the sky, one clinging molecule after another. Water has yet another superpower. It's often called the universal solvent, and it truly earns the name. No other liquid dissolves more kinds of substance, because that lopsided molecule acts like a tiny magnet. Its oxygen end is slightly negative, its hydrogen end slightly positive, so it pries other substances apart. Salt, sugar, minerals, even gases, get surrounded by water and swept into solution, molecule by molecule. Given enough time, water even dissolves solid rock, patiently carving out vast caves and deep canyons. That's why the sea is salty. Over millions of years, rivers strip minerals from the land into the ocean. And that same solvent power lets the water inside your cells carry the entire chemistry of life. Water hides one more oddity. It is astonishingly stubborn about ever changing its own temperature at all. It absorbs an enormous amount of heat before it warms up, then releases that heat slowly as it cools. This high heat capacity lets the oceans store staggering warmth and steady the entire planet's climate. Coastal towns stay mild all year, while inland deserts swing between scorching days and freezing nights. Turning liquid water into vapor demands even more energy, and your body cleverly puts that to use. When you sweat, evaporating water carries away a rush of heat, cooling you down on the hottest days. The very same effect powers thunderstorms, hurricanes, and the whole water cycle wrapping around our planet. Here's a puzzle that still splits scientists today. Sometimes hot water seems to freeze faster than cold. It's called the Mpemba effect, a mystery argued over since Aristotle, and still never fully explained. A recent study suggests it's real, but mostly down to chance, hiding in tiny, uncontrolled experimental details. Water can also stay liquid far below freezing, sitting perfectly still, just waiting for a single trigger. Disturb that supercooled water, and it flashes into solid ice in an instant, right before your eyes. It's also the only substance on Earth found naturally as a solid, a liquid, and a gas at once. And in 2026, scientists in Stockholm caught water behaving as two distinct liquids blended together at once. Using powerful X-ray lasers, they glimpsed a long-predicted hidden state that may explain many of these mysteries. Almost every strange thing water does traces straight back to those bent, restless, deeply sticky little molecules. Their hydrogen bonds form and break billions of times each second, quietly rewriting the rules of matter. So the most familiar liquid on Earth is also the strangest, and life itself exists because it is.